Okay, today we're going to be factoring the difference of two squares. Earlier we had worked with just the difference of squares, and that formula was this one that said a plus b times a minus b is equal to a squared minus b squared. So this is the same similar type of questions, except they're going to give us the a squared minus b squared, and we have to figure out what the two parentheses are. Alright, so in order to do this, we've got to know two things. We've got to be familiar with taking the square root. So if I have the number 4, what's the square root of 4? And if you remember, a square root is where it's two numbers that are the same that multiply together to give you the inside number. So we're looking at what's two numbers that multiply together give me 4, and it's 2. Okay, let's take the square root of 9. Two numbers that are the exact same numbers that multiply together to give you 9. 3 times 3, so the square root of 9 is 3. The square root of, let's say, 16. So two numbers, the exact same numbers that multiply together to give you 16, and those would be 4 times 4. Okay, and then one more, like 49. Two numbers that multiply together to give you 49, they're exact same numbers, which would be 7 times 7. Alright, one other thing you need to know is if you have like x squared and you take the square root of x squared, you end up with just x. Okay, because what that does is, like, if you have having a hard time with this. If you have like y squared and you take the square root of y squared, these cancel out and it just leaves you what's inside the square root symbol. Okay, so we just need to know that in order to do this. So on number 1, on our example, we are going to be taking the square root. So you've got your x squared, so we're going to take the square root of x squared and we get x. We're going to take the square root of 49 and we get 7. And I'm going to make this a positive, and I'm going to write the exact same terms except with a negative in between them. And there I just factored my difference of squares. Okay, number 2. We're going to take the square root of y squared, and it just becomes y. The square root of 4, it is 2. This is y plus 2, and y minus 2. Okay, the next one. We're going to take the square root of 9, and that is going to be 3. Then you take the square root of a squared, which is a. Take the square root of 4, which is 2, and then you have 3a plus 2, and then 3a minus 2. Okay, now let's look at this one. We've got 5 and 45. I don't know what the square root of either one of those are. It's not a perfect square, so there's no square root of it. So I'm looking at maybe there's another option here. Could I take out the 5 and I end up with m squared? Can I take out a 5 from the 45 and end up with a 9? And it's negative. Now I'm able to factor the difference of squares. I'm going to take the square root of m squared, which is m, take the square root of 9, which is 3, going to make this a plus, make this a minus, and then I'm going to keep that as a 5. Okay, number 5. Now, I don't know there's no perfect square of 12, because remember it has to be a perfect square. It has to be two numbers, the exact same numbers that multiply together to give you 12, and there's no two numbers that are exactly the same that would give me 12. So therefore, I have a 12 here and 12 here. Can I take the 12 out and get y squared minus 1? because 12 times y squared is 12y squared. 12 times negative 1 is negative 12. Now, do I have a difference of squares that I can factor? And I do. I can take the square root of x squared and get x, take the square root of 1 and get 1, and this is plus, and then x minus 1, and it's going to be 12. Okay, now number 6. Number 6 looks like it's pretty straightforward. But then I look at this, and if I take the square root of 36, I get 6. If I take the square root of c squared, I get c. If I take the square root of 225, and if I do it on a calculator, I find it's 15. And then if I write it as a difference of squares, I've got this. But then upon closer look, I say, wait a minute, these both have a 3 in common, so I need to take out a 3 out of here. So that's going to be plus 5, because 3 times 2 is 6, and 3 times 5 is 15. But these also have a 3 in common, so I'm going to take a 3 out of this, and I'm going to get this. Okay, because when I multiply this, I get 6. When I multiply this, I get negative 15. So now, I'm going to multiply these two 3's together to get a 9 to simplify it. And this is going to be my answer. Because if I looked at the very beginning, which I probably should have done, I should have recognized that I could have taken a 9 from the 36, because 9 times 4 is 36, and I could have taken a 9 out of 225, and let me show you. That would have been 2, that's 18, and then borrow, so that's going to be a 4, 45, and I could have gotten a 25. Okay, so now, if I take the square root of 4 squared, I get a 2. Square root of c squared, I get a c. Square root of 25, I get a 5, and then I get plus, and then I get a minus, and then I have a 9. So I ended up with the same thing. The first way that I did it, where I took the square root of both these, were probably easier than thinking about what was factored out. But then I have to remember I need to pull what's common out, and then I multiplied the 3 times 3 to get the 9 to make it a 9 on the outside. Alright, so most of them are pretty simple. You might come across a couple that are a little complicated. So just take your time and do your best, and that is factoring difference of squares.